Our truth burns bright. We stand as one, exposing your lies tonight. Tonight, no scam or false prophet can dim our light. Keep it unfiltered, let pride take flight.
Shut up, you dumb, you sound like a coon. Get out, stay clear of this room. We proud, we black, rich, and forever stay paid. They lies and killing spraying from the soil they mislaid. Their tales a sham, cooked up by scammers who toil. So shut up, chief X, you're a grifter, spoil. Your bow-hammer drivel ain't your soul. Coptic verse, their language is liturgical, not the rehearsed curse. While Ethiopian and Nubian cops and Cairo so merciful. Drop troops surgical, leaving your myths pitiful.
You act like black folks ain't speaking Remy, give me your idiocy. Runs deep, can't study, can't even see. Bubble brother, hush up before I knock your sugar out. Don't twist our ancestors' lore, I'll butcher your clout.
Unity in Kemet, our truth burns bright. We stand as one, exposing your lies tonight. Tonight, no scam or false prophet can dim our light. Keep it unfiltered, let pride take flight.
You claim you came from Baltimore, just more trash on display. I bet the faithful flock was up, dusting your ass away. Into that fat orange cat, you're dumber than a box of rocks. Pushing assimilation as politics to shock like cheap mock.
We spot you from a mile, your act just isn't slick. This is real knowledge, not your kuna logical scholarship. If you scared, you should be watch as I spit. God's flame, no bars, no game. You're done when I put you to shame.
When your twisted lies crumble and your fake talk fades, our united voice echoes, truth never degrades. From the ashes of deceit, our spirit invades. In Kemet's name, your false crown forever cascades.
Rosie aka Amir, your scams are total disgrace. Spitting a whip on one jargon at a crooked scheme and pace. Your twist words confused, try to carve up a space. A fraud, your fake gospel body begin with no base. You try to fool slow raps with your bogus empty guys, but your clumsy act crumbles under truth's piercing eyes. Kemet stands united, no room for your deceitful art. Step aside, false prophet, your lies won't break a heart.
Unity in Kemet, our truth burns bright. We stand as one, exposing your lies tonight. Tonight, no scam or false prophet can dim our light. Keep it unfiltered, let pride take flight.
Unity in Kemet, our truth burns bright. We stand as one, exposing your lies tonight. No scam or false prophet can dim our light. Kemet, unfiltered, black pride takes flight.
What's up, everybody? What is going on? We are about to read this article that we have here, from the King's monologue. Shout out to everybody in the building. Just give me a one in the chat if you can hear me loud and clear. I don't suspect that there will be any issues with that. So here we have an article from King's monologue. It's called Erasing Bias in African DNA. And, this is a much needed, article because so many people, when they're dealing with DNA analysis, they come under the impression that, DNA is surefire. It can't be wrong. DNA, we could take it without any reasonable doubt. But in reality, there's a difference between the fields. Population genetics doesn't necessarily have the same level of integrity as, medical genetics. And that's just one example. but there are a lot of biases that can come in with respect to the framework. The framework that the scholars have is really, really important. And this study is going to get into this. And on the right, I just have an example of medical DNA analysis from Dr. Jean-Philippe Gourdin. And, he's just analyzing tuberculosis in the Middle Kingdom. And again, this is something I've gone over, ad nauseum. The strain of tuberculosis within ancient Kemet in the Middle Kingdom is the same as that which exists in Senegambia in L5 and L6, right? So we're going to get into the article. So this says, shout out to Jeffrey Guillot. Hope I said that correctly. For the one, and we're about to get into this. So it says, evaluating population genetics and ancient DNA interpretation in Africa. Methodological bias and Eurocentric historical narratives in modern genomic studies. Let's see here. That doesn't, that screws it up. No. Okay. Want that to, there we go. Shout out to Smelly. If the DNA don't match all the other evidence, the DNA should be the first thing reconsidered. No, definitely agree with that. So this is the abstract. The field of ancient DNA and population genetics is a new field that is rapidly expanding over the past decade, offering new insights into human history. Innovations have advanced our ability to collect and analyze DNA. And these innovations in public and academic use exposes the requirement for the field to undergo the kind of scrutiny and methodological protocols that we have become accustomed to in legacy fields of historiography. This relatively novel field of study presents exciting possibilities for historians to corroborate historical evidences with genetic confirmations. However, when applied to the African continent, particularly North and East Africa, there is a growing body of evidence suggesting the field suffers from systemic methodological inconsistencies and Eurocentric interpretive biases. This paper critiques 5 influential studies, Schunemann et al., Laurent et al., Salem et al., Mubtaj et al., and Merez et al., through the lens of Lachance and Tiskov's 2013 seminal review on S&P ascertainment bias. And this is going to be a really, really important fact that we're going to get into, how Eurocentric S&P bias skews history and genetics, towards Europeans and away from African affinity. This is really important. This is extremely important. By examining discrepancies in analytical weighting, for example, fluctuating prioritization of PCA, admixture, and QPADM, inconsistent reference population selection, and interpretive asymmetries in explaining African versus Eurasian ancestry, we reveal deep structural issues within the field which lead to biased reporting and a tendency for politically charged abstracts and conclusions. These skewed narratives are then sensationalized in media headlines. We argue for a paradigm shift towards more holistic, African-centered methodologies, equitable genomic sampling, and historically contextualized interpretations. So we're getting into it. It is imperative that researchers are aware of the effects of S&P ascertainment bias. Now, shout out to everybody in the building. Right now, we're just going over this article by the King's Monologue. And he made a pretty good article dealing with some of the flaws within genetics studies. And we're just going to get into the problems of this paper. So the interpretation of ancient DNA has revolutionized our understanding of human prehistory. Yet in the case of Africa, the most genetically diverse continent and the cradle of humanity, studies often rely on analytical frameworks and genotyping tools that fail to reflect this diversity. This paper critically evaluates how methodological biases and historical narratives shape the conclusion of major ancient DNA, focusing on African populations with an emphasis on North and Eastern Africa. So despite the growing influence, ancient DNA is still a relatively new scientific field, and its application to historiography is in the early stages. The temptation to draw definitive conclusions from limited data sets remains problematic. Across most ancient populations, including those in Africa, the number of high-quality, securely dated genomes remains far too low to support sweeping historical generalizations. Interpretations based on a handful of individuals are frequently extrapolated into narratives that imply continental-level trends, when in reality, the genetic landscape of ancient Africa remains vastly underexplored. Without broad and diverse genomic sampling, and in the absence of interdisciplinary corroboration, genetic studies risk overreaching in their claims. And then this is another, selection from Tishkoff. One advantage of whole genome sequencing is that S&P ascertainment bias is reduced compared to alternative genotyping technologies. This lack of S&P ascertainment bias is critical for accurate population genetic analyses where allele frequency distributions are used to infer demographic history. So there is a inconsistent and fluctual weighting of PCA, admixture analysis, and QPADM, right? So you can see in these studies there's a inconsistency on the way that these scholars place an emphasis on different analytical tools, right? Shout out to Passports and Profits. Thank you for tuning in, and everybody in the building. So in Schuneman et al. Study, admixture and F3 statistics are used to emphasize the sub-Saharan component of post-Roman Egyptian mummies. But PCA, which clusters these individuals closer to East Africans, is de-emphasized. So within the famous Abasir Malek study, they boosted, F3 statistics when it supported their argument, and then they basically, reduced PCA when it, went against their argument. So Lorenz et al. Study lends heavily on outgroup statistics and admixture to highlight Eurasian input in a 45,000-year-old Ethiopian genome, while downplaying the African substrate and the limitations of the S&P panel. Within Salem et al., the authors rely almost exclusively on outgroup statistics and QPADM while minimizing the relevance of PCA, which shows affinities between Takakori individuals and modern Sahelian groups like the Fulani. Mubtaj et al. Study focuses on isotopic evidence, but draws genetic parallels without discussing ascertainment bias or PCA relationships with African groups. And again, Morez et al.'s study of Nurat using QPADM to infer Eurasian-related ancestry in an Old Kingdom Egyptian doesn't fully reconcile these conclusions with admixture or PCA signals that clearly point to an African affinity. So as you can see here, basically the framework that they're coming in, has a large influence on the particular sources of information that they support and those that they don't, right? So you can clearly see this. So like they're basically trying to show Eurasian affinities, and from those Eurasian affinities, they're working backwards from their conclusion. So they're going to handpick certain tools that show that there is Eurasian connection, and then they're going to reduce or de-emphasize a tool that shows an African relationship. And you can see this throughout these studies. It's pretty embarrassing, really. Just the amount of chicanery that happens, with respect to these studies. But, this is something that we have to pay attention to, and we have to be very, very clear with checking. Shout out to Pan African James. See you in the building. Was good. We just going into the flaw of genetics. You won't see dudes like Ngozi or Gullah or even Ankh or even Chief X, talk about the flaw of, this analysis. Shout out to more ones in the building. Appreciate you for stopping by. And again, we were just going over the fact that these authors of these genetic studies are biased. They want to prove Eurasian affinity for certain African civilizations. So they'll cherry pick data and they'll handpick certain tools. They'll have different K factors within admixture plot just so that they could justify the framework, the built-in framework that they're coming in with. So again, the selective use of methodology creates an inconsistent evidentiary hierarchy. Tools that support Eurasian are elevated, those suggesting African continuity are marginalized or treated as secondary. Morez entirely discarded the consistent outcomes of multiple PCA results in admixture, clustering, consistently relating Takakori to the geographically and historically Fulani and Kenyan pastoralist of Africa, instead opting to elevate important FST outgroup statistics. And I think he meant Salem et al. In this case, which also introduced substantial distance between African and Takakori samples. Right, in the outgroup analysis. No other study denigrates the outcomes of multiple PCAs and admixture clustering in this manner. And James says, I've been working on this also. Shout out to Sarah in the building. Was good. And yeah, this is just a really, really important thing. Now, nobody like King's monologue was the first person to get me hip to the S&P bias. So regardless of what you're doing within genetics, the fact that there's S&P bias is going to shift all of the data in the direction of Europeans. So you really don't have any accurate genetic analysis or genetic studies when you have S&P ascertainment bias. So then you have narrative asymmetry and historical framing. The narrative and the historical framework is very important because scholars go in with the framework. They don't even go in to test it. They go in under the assumption that their framework is valid, and then they look for data to justify the framework, right? This is the way that propaganda is generated. In the Schunemann et al., the appearance of African ancestry is almost exclusively attributed to the trans-Saharan slave trade, while Eurasian admixture is left unexplained, normalized, or attributed to migration, right? No mention is made of well-documented historical slave trades from the Eurasian steppe, Anatolia, or southern Europe into Egypt, despite ample archaeological and textual support. Lorenz et al. Presents Eurasian admixture in East Africa as evidence of a massive Back to Africa event without fully addressing the potential for deep shared ancestry or the limitations of the S&P panel used. So this pattern of over-explaining African components as recent, invasive, or disruptive within North and East Africa, while treating Eurasian elements as normative or ancestral, creates an imbalance in historical interpretation. So you have S&P ascertainment bias is the systematic deviation of population genetic statistics from theoretical expectations. And it can be caused by sampling a non-random set of individuals or by biased S&P discovery protocols. Unless the whole genome of every individual in a population is sequenced, there will always be some form of S&P ascertainment bias. So again, you have the exploitation of sensationalist and racially charged narratives. In several studies, scientific interpretations are undermined by sensationalist or politically charged language that appears disconnected from the actual data. For example, the Schunemann et al. Abasir Malek study was widely publicized with headlines that implying that ancient Egyptians were genetically European and only became sub-Saharan due to slavery. This headline narrative, unsupported by archaeological or genetic evidence, reflects a broader trend of weaponizing genetic data to reinforce anti-African sentiment. Similarly, Merez et al. 2025 disproportionately emphasized Eurasian admixture while virtually ignoring Africa's relevance to the subject's individual's ancestry. Despite clustering analysis and geographic context pointing towards strong African connections, the framing and public communication of these studies often do more to confuse and clarify, reinforcing racially biased interpretations while presenting them as objective scientific fact. Shout out to Smelly, Mystery Plots Nah. The Eurocentric genomic pipeline, from data collection to interpretation. The issues highlighted above are not merely analytical, they are embedded in the entire data pipeline. And this data pipeline is important because you need to know the way that Eurocentric bias seeps into genetic studies and the way that they basically cook the books in their favor. So you have data collection. Many African regions remain vastly undersampled, especially in the Sahel, Nile Valley, and Central Africa. This remains the case in spite of the significant excess in genomic diversity seen on the African continent, which geneticists consistently agree requires more, not less sampling on the continent to compensate for. Shout out to the Elder Patan. The building was good. Appreciate you for stopping on in. We having fun just, discussing some of the issues in genetic data, debunking the belief that many folks have that genetic data is infallible, it is unbiased, it is clearly biased. And you can see from this article written by the King's Monologue that this is so. So then you have the genome typing arrays, and these are the S&P panels that are biased towards Eurasian S&Ps, reference populations. Key African groups are often missing from QPADM or FSTEM models, leading to substitution by Eurasian proxies. Then you have the analytical tools. Tools like QPADM and outgroup F3, F4 statistics are sensitive to reference panel completeness in S&P coverage, a fact often unacknowledged. Conclusions frequently lean towards a Eurasian-centric storyline, reinforced by methodological and reference limitation. To resolve these issues and prompt scientific integrity in African ancient DNA studies, we proposed the development and use of African-specific S&P panels, prioritization of whole genome sequencing over sparse S&P arrays, inclusion of broader and more relevant African reference populations in all models, methodological transparency and consistency across studies, critical engagement with historical narratives, avoiding oversimplistic or Eurocentric explanations, and greater editorial oversight in the framing and promoting of findings, particularly to avoid sensationalism in public discourse. The value of population genetic data is maximized when researchers are aware of existing biases. Whole genome sequencing reduces the amount of ascertainment bias we encourage researchers to use high coverage sequencing data whenever it is feasible. So in conclusion, the studies examined here represent important milestones in ancient African genomics, but they also illustrate deep methodological and narrative flaws that require urgent correction. Without reform, the field risks perpetuating a skewed vision of African history rooted not in evidence but in the legacy of biased scientific frameworks, continuing a dying legacy of the deliberate European misrepresentation of history. And there you have the sources right here. Right there. So, and even this Lorenzenthal study, I'm not as familiar with it, but I think it's dealing with Motor Man. And there was a correction, done on that study, by numerous scholars who showed that Moda man had no Neanderthal ancestry. So that needs to be stated. So genetics is like statistics. It can be easily manipulated to say anything to the reader that is unaware of the methodology. Absolutely. Shout out to Elder Patah, Passport and Profits. Yeah, so I mean, this article, I highly, suggest that y'all read this article from King's Monologue on evaluating ancient DNA interpretation in Africa. It's really, really important, and I'm gonna get into some of his other papers. I think there was a paper that I wanted to read. He has a lot of papers here. Let's see. There was one that I wanted to. Maybe we could go to some of his reconstructions. Yeah, I think that's a good idea. So let's look at Ramses II here. And he goes over the source material. Like, I really like the way that he uses the actual sources of the statues, because most times, European reconstructionist artists don't use them, and they come up with something that looks nothing like the popular representations of the statues. So he had a lot of primary evidence, and so like you have restorations that they have attempted, and it's funny how they base their reconstructions off of the mummified face with the distortions of the soft tissues. It's really, really fascinating how they try to get away with it. You have decomposed soft tissues, and they use the decomposed soft tissues and the fake prop to promote, this type of flawed head shape. So you have like the nasal bridge was broken, so like, and the cavity was packed with resin seeds. So basically, like, the nose cavity was packed and, to prevent collapse. So the way that the mummified remain looked is not at all related to what it is. And he did a phenotype analysis, of close African phenotypes. If I'm not mistaken, these people, Mutesa would be from the Great Lakes region. So like, you can see some similarities between Ramses and Mutesa there. Really clear. I mean, it's almost uncanny how similar they look. And then you can see the Afar, East African, populations that, are connected to Ramses. So, just from the combination of different data of related populations, you can see the overall overlay. And I mean, that matches pretty perfectly, with the statue, and you can see the transition there. And, it's just very, very helpful to have this displayed just despite the propaganda. I think that's pretty realistic. Looks like a pretty standard Northeast African person in the Neolithic. I think this is a really, really good reconstruction. Shout out to King's Monologue for this one. And he has like a little final. Yeah, so this is the type of stuff that you'll never see in any of the Western Academy at all. You'll never see this type of stuff. You know, and it's just way more realistic. And this is kind of the reason why they won't. Queen T is another one. Like, that's the one that, I heard some people try to deny that she was black, which is just crazy. These guys are just clowns. This one is just so easy to put together. And you can see the prognathism within black female representation across the African continent. And you use the same overlay technique with this one. This one looks a lot like Michelle Obama or Tiana Paris, or, variety of different dark-skinned actresses. Very, very beautiful stuff. And yeah, I like this. I really like this. This is a really job well done with respect to that. So yeah, I just wanted to take a good look at these reconstructions. I think I got a little bit more time. Like, I may actually get into some of the ascertainment biases that we were talking about before. Just dealing with the fact that, a lot of us don't really know, where these sources are and how we can actually look into them to be able to find the truth. So right here, I have the article, and I'm going to paste it there, and then you can see what it is. I'm going to need to move this over. There we go. So it's just saying that genotyping arrays can paint strikingly different pictures about demographic history and natural selection. This is because genotyping arrays contain biased sets of pre-ascertained SNPs. In this short review, we use comparison between high coverage whole genome sequences of African hunter-gatherers and data from genotyping arrays to highlight how SNP ascertainment biases distorts population genetic inferences. Sample size in the populations in which SNPs are discovered affect the characteristics of observed variances. We find that SNPs on genotyping arrays tend to be older and present in multiple populations. In addition, genotyping arrays cause allele frequency distribution to be shifted towards intermediate frequency alleles, and estimates of linkage disequilibrium are modified. Since population genetic analysis depends on allele frequencies, it is imperative that researchers are aware of the effects of SNP ascertainment bias. So they're basically showing how, the SNP bias is directed at the type of genetic diversity that is seen among Europeans and does not meet the mark when it comes to the diversity needed to effectively analyze African populations. That's right. They look at the grass and they deny that it grows from the ground. Very, very true. Very, very true. And so, you know, let's see how long this is. So I'm not gonna read this whole thing. I'm gonna just see if I can get DeepSeek to summarize it for me. I told it to summarize the main 20 points of the article based upon the content. And let's see what it does. You know, a lot of times when I use AI, I try to check and see if it's legit. I test it out a little bit, you know, I run it through the mud just to see if I can trick it. So it was giving me the 20 facts based upon the content in the article, parsed out. So it gave me my 20. So let's run through them. So it says S&P ascertainment bias is a systematic deviation in population genetic stats caused by using a non-random pre-selected set of S&Ps, typically from genotyping arrays. So sequencing versus arrays. Whole genome sequencing provides a much less biased view of genetic variation compared to S&P genotyping arrays. Arrays use S&Ps that were previously discovered, ascertained in specific populations, which skews all subsequent analysis. So that's a source of bias in the arrays. Sample size effect. Even with sequencing, small sample size bias allele frequency distributions because they are less likely to detect rare alleles. So even when you do whole genome sequencing, if you have a small sample size, you could still have a degree of bias. S&Ps discovered in less diverse populations, Europeans, are a poor representation of the variation in more diverse populations, Africans. So if you have, you know, Eurocentric, you know, genetic arrays, then you are not going to have a full spectrum view of what genetic diversity is. So the older S&Ps on genotyping arrays are biased towards older alleles that are present in multiple populations. So ascertained S&Ps cause allele frequency distributions to be skewed away from rare alleles and towards intermediate frequency alleles. And then this bias can lead to incorrect inferences about demographic history, such as falsely suggesting a population has undergone a bottleneck, when that definitely may not be the case. And then you have an overestimation of divergence. Measures of population differentiation in FST stats are inflated by ascertained S&Ps, overestimating the genetic differences between groups. So this is pretty easy. This is a layup. So then you have biased genomic coverage. Genotyping arrays have an uneven distribution of S&Ps across the genome, being enriched in some regions and deficient in others. So then you have linkage disequilibrium, and it impacts the linkage disequilibrium estimates. So these decay curves are distorted, and ascertained S&Ps show a higher levels of LD than is actually present. And then this also affects the selection scan. You know, scans for natural selection are highly affected, often leading to different and sometimes incorrect genomic regions being identified as targets of selection compared to sequencing studies, right? Then there's a robustness of some tools. Some tools like structure for ancestry inference are relatively robust to this bias because they use many loci. But ascertainment bias is a bigger problem for SMPs than for microsatellites, and a much bigger problem for indels. So the best way to avoid bias is to use high coverage whole genome sequencing, and you have to make sure you have a large sample size. When sequencing is not feasible, using haplotype-based statistics can reduce the impact of ascertainment bias. So then one correction method involves modeling SMP discovery process to modify the raw genotype data and frequency to raw genotype data and adjust allele frequencies. Another method is to explicitly incorporate the known or inferred ascertainment scheme into theoretical population genetic models. So researchers must be aware of the potential for ascertainment bias in their data, as it fundamentally affects most population genetic inferences. Studies should always describe the ascertainment scheme of the SNPs used so that the potential for bias can be assessed. So James said, this is why I called for structural variant and whole genome sequencing testing without biases will continue. No, absolutely, absolutely. And yet King's Monologue wrote the first article that we read, and it's on his website, tkmadu.com. I thought it was pretty good, so I decided to read it. So for those who may not understand this, I'm going to get all of the different points. So like say, based upon the vocabulary explain all of the technical phonetic terms in language that So I wanted to explain all of the different vocabulary that we used in a 7th grade level so that the largest amount of people can understand, what we've been going over. So it's basically going to get into just like what we're dealing with, more advanced people like James in the chat and others who have been dealing with DNA for a long time. Y'all are going to know what this is, but for those who are unaware, who are not basically familiar with this is going to be able to help you a little bit. This is going to help you a lot, actually. I'm just going to get into a lot of the specifics. So if you have any questions, feel free to put them in the chat. You can support the channel through Cash App or by hitting the dono button here so that we can continue to, come back and be able to break this stuff down. So I think it missed one I wanted. Yeah, he has an article about this as well as like other different, like he has a presentation where he dealt with the affinities between the pharaonic population and contemporary inter-African populations. So just getting into some of the basic terms, that we went over. So you have S&P ascertainment bias. And this is the main problem. If you wrote your lunch survey questions only by asking your 5 best friends what they like, your survey would be great for your friend group, but they would miss all the unique foods other kids love. Your survey is biased towards your friend's taste. Genotyping arrays use a survey of SNPs chosen from a small specific group of people, i.e. Europeans, so they have a biased view of human diversity. Their perspective on diversity is Eurocentric. It is definitely biased. So then you have genome. This is the entire set of instructions Like a massive recipe book that tells your body how to build and run itself, it's made of DNA. And this is the molecule that carries all those genetic instructions. It's like the paper and ink the recipe the book is written with. A gene is a specific section of DNA that holds the instructions for making one particular thing, like what colors your eyes will be, etc. Right? The variant mutation, a spelling change in the DNA instructions. So most are harmless typos. For example, a recipe might say add 1 cup of sugar instead of add 1 cup of salt. And that's a variant or mutation. SNPs, this is a single nucleotide polymorphism. This is the most common type of genetic typo. It's where a single letter in the DNA code is different between people. For example, one person's DNA has an A and another person's has a G at the same spot. The allele, this is just a fancy word for the version of a SNP that you have. Using the example above, you could have the A allele or the G allele. Derived allele, the new changed version of the allele. The typo, the ancestral allele is the original older version. Right, so these are just different facts. So these are the how tools for reading DNA, right? You have the whole genome sequencing, reading every single letter in a person's recipe book genome. It's the most complete way to find all the typos, variants, even the rare ones. This is like giving your entire school the blank space to write down their favorite food. You'll get every possible answer, right? So the whole genome sequencing is the most clear way of discerning what is what. And it's a question. So is the purpose of this dialogue to show the discrepancy of how genomic information can be used in propagandized ways, even though the science is perfectly utilized? I would say, yeah. I mean, it's to show the bias within genetic studies. That's essentially the goal here. Genetic studies are not perfect. Then you have genotyping array or SNP chip. This is a clever shortcut. Scientists pre-choose a set known of common typos, SNPs, and check for those. It's like a multiple choice survey where kids can only pick from options like pizza, sandwich, or salad. It's fast and cheap, but it misses answers like sushi or leftover spaghetti that weren't on the list. This is kind of like samples are used politically to sway ideas. Yeah. So you have the allele frequency, right? Or you have ascertainment. This is the process of choosing which SNPs go on the genotyping array. If they only choose SNPs common in people from Europe, the array is Eurocentric. It's ascertained for Europe. I don't see an article by Gordine. The article from Gordine is written in French. He submitted it. It's probably behind a paywall. He submitted it within the Diop conference at the end of 2023. That's where I first saw his presentation as an attendee of the conference. But yeah, the article that he wrote is definitely a French article, likely behind a paywall. So, where were we at? Allele frequency, how common or rare a specific allele is in the population. And the frequency distribution is a graph showing how many typos are very common, somewhat common, or very rare. A bias survey makes rare typos look much more common than they actually are. And then linkage this equilibrium, how likely two typos, SNPs, that are close together in the recipe book are to be inherited together. If you see one, you can predict the other. Biased SNPs can mess up scientists' measurements of this togetherness. Then you have population differentiation. This is a measure of how different two groups of people are genetically. Ascertainment bias can make two groups look more different than they truly are. The demographic history, story of a population's past, like its size, if it went through a famine, a bottleneck, or if it mixed with another group. Using biased data is like trying to write a history book using only a few biased sources. You'll get the story wrong. And natural selection. This is a process where certain traits become more common because they help someone survive in a certain environment. It's like if a school in the hot climate started favoring ice cream as a lunch option. Biased data can make it hard to find which recipes were truly selected by evolution. So then you have the effective population sizes, an estimate of how many breeding adults were in a population in the past. Biased data can make it seem like a population was much smaller than it really was. So then, you can correct the bias. You can use haplotypes, which you already know about. So, and these bigger chunks can be less affected by bias rather than looking at single SNPs. So then you have indels. These are insertions or deletions. This is the type of genetic typo where letters are either added in an insertion or taken out in a deletion from a DNA sequence. It's not changing a single letter like an SNP. It's like accidentally adding an extra word to a sentence or forgetting a word. Original sentence, the dog bit the cat. The insertion is the dog did bit the cat. The deletion is the dog bit cat. So in the structural variant, this is a large-scale change to the recipe book genome. It's much bigger than an indel. Copying a whole paragraph or even a chapter and pasting it in multiple times. Taking a whole paragraph and moving it to different parts of the book. That's translocation. Flipping a paragraph, that's inversion. Deleting an entire paragraph, large deletion, right? So these big changes can have major effect on how the recipe actually turns out. And then you have genetic diversity, bottleneck and founder effect. Bottleneck, a giant spilled milk disaster wipes out most of the lunches. Only the few lunches on the high table survive. The future lunches of the school will be based on the few surviving meals, so there's much less diversity. And that's the bottleneck, the founder effect. A small group of kids break off to start a new school. They only took tacos with them. The new taco school will have much less lunch diversity than the original big school. This happened when humans migrated out of Africa. Right, then you have ancestral versus derived allele. That's pretty self-explanatory. And then linkage disequilibrium. We already discussed that. How close are certain typos or alleles together. Exome sequencing, right? So this is a way, it's cheaper alternative to reading the entire recipe book or the whole genome. Instead, you only read the table of contents, and the recipe titles. Low coverage sequencing, you don't cover a large amount of the genome. SPG site, this is a specific site of the DNA code where a C letter is right next to a G letter. These spots are like hotspots for typos. They mutate and change at a much faster rate than other spots. Scientists often treat them separately in their calculations because they are so error prone. And tag SNPs on the genotyping array. Scientists can't test every single SNP, so they pick one SNP that acts as a tag for a whole group of other SNPs that are inherited from it. It's like an election exit poll. You don't ask everyone who they voted for. You just ask a few tag people who represented a larger group. So again, these are just the different vocabulary words. And James went into structural variants. And I kind of want to ask it a different question with regards to the structural variants. So I'm gonna ask it, the ways that the structural variants change and the indels change someone's genome. I'm gonna ask it that. See what it comes up with. I kind of want to look into a spot. Yeah, I'm gonna look into this spot about evolutionary history. Shout out to everybody in the building. Shout out to everybody in the building. So these are just ways that structural variance holds up to chematology. These are ways that structural variance can influence a DNA as well as indels. So if you have an insertion, you could have a frameshift mutation. So this could lead to genetic disorders, cystic fibrosis, etc. Then you have a deletion. You could have some serious consequences with respect to protein production, etc., etc. James said structural variance versus whole genome sequencing. And then T2T. What is T2T? Methods are the gold standard in genome testing in 2025. Yeah, I agree with the first two. I'm not as familiar with T2T, but yeah, definitely. So then you have structural variance. So duplication, extra copies of a gene. This might mean your body might produce too much of that protein. Some people have extra copies of a gene called CCL3L1. This can make them more resistant to HIV infection. In other cases, this can cause diseases like Charcot-Marie tooth disease, where a duplication leads to nerve damage. Then you have deletion. Williams syndrome is caused by a deletion of a chunk of chromosome 7. People with this syndrome have elfin face, heart problems, and are often very friendly and sociable, but have learning difficulties. A crucial set of instructions is just missing. Translocation is a broken gene. The move might happen in the middle of a gene, breaking it and creating a non-functional protein. And then the move paragraph might get placed into the next sentence, creating a brand new fusion gene that has a completely new and often harmful instruction. This is translocation. So a specific translocation between chromosome 9 and 22 creates the Philadelphia chromosome. A fusion gene causes cells to divide uncontrollably and is the direct cause of most cases of chronic myeloid leukemia. Then you have inversion, like translocation. This can break a gene if the flip happens in the middle of it, even if it doesn't break a gene. It can separate a gene from its on and off switch, its promoter, so the gene never gets turned on. The instructions are all there, but they are unreadable and inaccessible. So SMP changes have minor effects. It rarely causes diseases like sickle cell anemia. And then indels, frameshift, usually disastrous, creates broken, non-functional proteins that can cause serious genetic disorders. And the structural variance, major effects can lead to missing genes, extra genes, or dangerous new gene combinations, strongly linked to cancer and major developmental disorders. So yeah, these are just examples of the way that these different situations can cause harm to folks. So what I'm gonna do here, I'm gonna get this up here, my nigga. Yeah, I mean, it's pretty clear that, genetics has and has always been biased. And we're just getting to the bottom of this S&P ascertainment bias. And we've spoken about its Eurocentric leanings. And we're going to get into, what needs to be done in order to fix the problem. Marissa was giving us some facts. So again, this is going to get into the 15 sequence hunter-gatherer populations, and their genomes contain millions of previously unknown genetic variants. So the ascertainment bias is a systematic deviation from true genetic patterns caused by how and where the SNPs were discovered. SNVs identify archaic introgression, missing SNP testing. They use only HO 1240K panels. I'm gonna definitely look into that. And then you have, bias as many sources. It arises from using small sample sizes, non-uniform discovery protocols, and from choosing SNPs from specific populations. So a small size is much more likely to find common genetic variants and completely miss rare ones. Since African populations are more genetically diverse, using SNPs discovered in less diverse populations like Europeans creates a biased picture of African studies. Genotyping arrays are enriched for SNPs in some genomic regions like the MHC and lack them in others, unlike the even coverage of whole genome studies. So then you have SNPs on genotyping arrays are skewed towards intermediate frequency alleles, while whole genome sequences reveal a much larger number of rare alleles. This bias leads to incorrect estimates of population divergence times and ancestral population sizes and migration rates. This bias leads to incorrect estimates in migration rates. The bias makes it look like a population has undergone a recent shrinkage in size, which may not be true. SNPs on arrays are on average older than those found through whole genome sequencing, meaning they are less useful for finding recent population-specific genetic changes. Then you have measures of genetic differentiation are artificially inflated by ascertained SNPs, making populations seem more different than they actually are. This is definitely the case within the African context with the Eurocentric bias of the SNP arrays. You may find a population like Eastern Africans who may be close to the out of Africa hub, and they view them as like super divergent from, West and Central Africans. And this is partially due to SNP ascertainment bias. So SNP ascertainment bias can cause both false positives and false negatives when searching for genes that have been shaped by natural selection. And then you have the distortion of linkage disequilibrium. Arrays overestimate the amount of linkage disequilibrium, how strongly nearby variants are correlated compared to whole genome sequencing, right? So again, all of this stuff was seen within the analysis of those 15 hunter-gatherer populations, and it's clear that, these genetic studies need to be corrected. None of these genetic studies are perfect, right? So that's what's up. As always, just look, policing where diversity needs within the studies and freedom of samples needs to be allowed. Exactly. And then South 12 came across something I overlooked. East Africans have 8 to 24% more ancestry than Europeans, East Asians. That's not true. That's definitely not true. South 12, stop. That's cap. So yeah, this has been basically, what I wanted to discuss, with respect to the study. If there's anybody, who wants to come up to have a conversation, talk about this, I may post a link. Maybe if I get some cash apps or something, I may post a link. But if not, I'm gonna close the show. and we're gonna get on to the next one. So shout out to everybody in the building. I'm gonna just be laid back. This is really over in my opinion. Tish called paper into this BS in 2017. That is what is good. I'm gonna play the outro. If y'all want to keep it going, bless the collection plate. If not, we finna be out.
Unity in Kemet, our truth burns bright. We stand as one, exposing your lies tonight. No scam or false prophet can dim our light. Kemet unfiltered, let pride take flight.
Shut up, you dumb, you sound like a coon. Get out, stay clear of this room. We proud, we black, rich, and forever stay paid. They lies and chemists sprang from the soil they mislaid. Their tales are sham, cooked up by scammers who toil. So shut up, chief X, you're a grifter, spoil. Your bow-having drivel and your soul. Coptic words, their language is liturgical, not to rehearse curse. While Ethiopian and Nubian cops and Cairo so merciful. Drop true surgical, leaving your myths pitiful.
You act like black folks ain't speaking Remy, give me your idiocy. Bugs deep, can't study, can't even see. Bubble, brother, hush up before I knock your sugar out. Don't twist our ancestors' lore, I'll butcher your clout.
Unity in Kemet, our truth burns bright. We stand as one, exposing your lies tonight. No scam or false prophet can dim our light. Kemet unfiltered, let pride take flight.
You claim you came from Baltimore, just more trash on display. I bet the faithful flock was up, dusting your ass away. Into that fat orange cat, you're dumber than a box of rocks. Pushing assimilation as politics that shock like cheating mock.
We spot you from a mile, your act just isn't slick. This is real knowledge, not your kuna logical scholarship. If you scared, you should be watch as I spit. God's flame, no bars, no game. You're done when I put you to shame.
When your twisted lies crumble and your fake talk fades, our united voice echoes, truth never degrades. From the ashes of the sea, our spirit invades. In Kemet's name, your false crown forever cascades.
Gauzy aka Amir, the scams are total disgrace. Spitting away with one jargon at a crooked scheme and pace. So twist words, confused, try to carve up a space. A fraud, your fake gospel body begin with no base. You try to fool slow raps with your bogus empty guys, but your clumsy act crumbles under truth piercing eyes. Kemet stands united, no room for your deceitful art. Step aside, false prophet, your lies will break a heart.
Unity in Kemet, our truth burns bright. We stand as one, exposing your lies tonight. No scam or false prophet can dim our light. Kemet unfiltered, let pride take flight.
Unity in Kemet, our truth burns bright. We stand as one, exposing your lies tonight. No scam or false prophet can dim our light. Kemet unfiltered, black pride takes flight.